Hello everyone. Today we are going to discuss one of the very important and interesting topic of data structure known as Tower of Hanoi, and you can clearly see the demonstration model in front of you. Before starting, what actually problem of Tower of Hanoi is? What is problem of Tower of Hanoi? There are actually three pegs or pole, you can say, which is clearly visible in this demonstration model: A, B and C. These are three poles, and in pole A you can see some discs are lying, and the discs are lying in increasing order, that is from top to bottom. And you can clearly see I took three discs. There could be more than 3, 4, anything. So what actually we are going to do in this model is that we have to transfer. The problem is that we have to transfer the entire set of discs from pole A to pole C with the help of B, but there are few constraints. The constraint is that you have to move one disk at a time, and you cannot place a bigger disk on the top of smaller disks. So if I'm taking an example, this one is wrong. You cannot put a bigger disk on the top of a smaller disk. So we are going to start the problem of Tower of Hanoi, and you can even clearly see in the board I have mentioned few steps. So we are going to take those steps the way we start. So now the problem is, as I told you before, that we have to transfer the same set in pole C, from pole A to pole C. So the first step which I am taking is transferring this smaller disk from A to C. This is what I have transferred, so I am just taking it. Now the second which I am doing is transferring this disk from pole A to pole B. The second step, from pole A to pole B. Now the third step, I am transferring this smaller disk from C to B. The third step, C to B. Then the biggest disk in pole A, from pole A to pole C. Then the smaller one from pole B to pole A. Fifth step. Then from B to C. Sixth step, B to C, I'm sorry. And the seventh and the last step is from A to C. Now you can see the same set which was earlier in pole A is now in pole C with the help of pole B. So this was all about problem of Tower of Hanoi, which took 7 steps. That is, if there are 3 disks, then it took 7 steps to solve the problem. So this was the demonstration model. As we have already seen that how this problem of Tower of Hanoi is solved through our demonstration model, which you have already seen. Now the thing is this: how many steps are required to solve a problem of n disk? Suppose right now there are 7 steps. It might be possible that just for 3 disks there were 7 steps. It might be possible that we may be having 4 disks, 5 disks, 6 disks, or n number of disks. So the particular formula for number of steps, that is the number of steps required to solve problem, is 2 to the power n minus 1. 2 to the power n minus 1, where n, this particular n, is number of disk. So I can prove this also. In our example, we took 3 disks. 2 to the power 3 minus 1 is 8 minus 1 is equal to 7. If we have 4 disks, then it will be 2 to the power 4 minus 1, which will be equal to 16 minus 1 is equal to 15. So if somebody asks you that if there are, the question is generally asked in competitions. I saw that if there are 10 number of disks, then how many steps will be required to solve this problem? So for 10 number of disks, 2 to the power 10 minus 1, which will be equal to 1, 0, 2, 3. So this was particularly about number of steps required. Now the question comes recursive functions. As we can see from our eyes that I have to put this particular disk from pole A to pole C, or pole from pole B to whatever it is. But can you imagine, can computer see all these things? No, computer is blind. In this case, computer is blind. Computer is not having anything to see. It needs some logic to solve the problem. And that logic that we are going to discuss now is the function recursive function, that how computer, we are going to match these particular steps when we do this particular problem, not by the demonstration model, but by using some logic. So this particular tower, the function tower, where n is number of disk, beginning, I'm talking of beginning pole, auxiliary, which I'm talking of middle pole, and the n talking of the pole C, last pole. This particular function is divided into three recursive function, that is tower n minus 1 from beginning and auxiliary, tower 1 beginning auxiliary end, and then tower n minus 1 auxiliary beginning and end. So we are going to solve this particular problem using these three recursive function, and you will surprise to see that this logic is going to produce the same result which we have seen through the demonstration model. So we start with this same recursive steps. So let us assume that this particular function tower as a T, we have three disks, we have three poles also, pole A, pole B and pole C. As I told you, this particular function is divided into three recursive functions, three recursive calls, which is, you can clearly write that, which is T n minus 1, which is 3 minus 1 is 2. Then from beginning to auxiliary, where beginning is A, now beginning is A and auxiliary is B, and end in middle and C. Then tower 1 from beginning auxiliary N, that is beginning to end, beginning, same sequence C, then tower n minus 1, you can see n minus 1, this which will be again 2, then auxiliary to end, here auxiliary is B, auxiliary and is C, and beginning, which is A, is in middle. So it's now divided into three parts. Okay, so how recursion takes place? First it will call the top function, the top, because recursion takes place through stack. So, and you know stack, what stack is LIFO based, that is last in first out, which is on the last will be called first. So this function will be called first, which will be again divided into three parts, but you have to make a note of it. Now the beginning is A, middle is C, that is auxiliary, and end is B. Now you have to consider these things. Again it will be divided into three same functions, then to n minus 1, which will be 2 minus 1, 1, then beginning to auxiliary, beginning which is A, auxiliary which is C, and end which is B will come in middle. Good. Then tower 1, beginning to end, beginning is A, end is B, and middle one is in middle. Then again same, n minus 1, 1, then auxiliary to end, auxiliary is C now, then auxiliary is C, and is B now, and middle one is A is here. Okay, then same 1, and you know if there is only one disk, you need not to use the middle one, you will simply put from starting to end. So if one disk is there, then you will simply transfer a disk from pole A to pole C. Though the required answer of this particular step is from A to C. We'll deal with them also. Again same set of sequence with this function also, which will be again divided into three parts. Tower, here beginning is B, middle is A, and the end one is C. Then again tower n minus 1, which will be 1, beginning is beginning to auxiliary, and in middle tower 1, same sequence B, A, C, and tower n minus 1, that is 2 minus 1, auxiliary to end, here auxiliary is A, end is C, and beginning and middle. Now starting again, one disk is only there, then the answer will be from A to C. One disk is only there, the answer will be from this to this, that is from A to B. One disk, that is from C to B. We have already solved this function. This, for this, one disk is only there from B to A, B to C, and from A to C. These are 7 steps. Step 1, 2, 3, 4, 5, 6, 7. And now you can clearly match these steps which we have calculated through demonstration model, and now which we are doing through this recursive function. And you will surprised to see the first step is A to C, and the computer calculates at A to C. Second one is A to B, A to B. Third one is from C to B, C to B. Fourth is from A to C, A to C. B to A, then B to A. B to C, then B to C. And last one, A to C, is A to C. So you can see that how computer, by using these 3 recursive function, how computer solve this problem. So this was all about Tower of Hanoi. Thank you so much. Thank you very much.